Okay, now we're going to move on to Newton's second law, which hopefully you remember. It's a very, very short law, and not our only equation related to forces, but the one that we're going to work with the most, and there's definitely fewer equations this time around. But remember, second law is F equals m times a, or force equals mass times acceleration. So, what that's saying is that in order to get an object to accelerate, so A, to speed up, slow down, change direction, to cause a change in the motion, a net force must act on the object. All right. What this net force means is when you figure in all of the forces, okay, because we've kind of talked about this before, like in the first law question worksheet with the pedaling the bicycle problem. Why do we have to keep pedaling the bike to keep going? Because there is a frictional force slowing you down. Okay, so in order to speed up on your bike, the force you apply has to overcome the frictional force and have extra acceleration to make you go faster. So what is meant by net force is that all forces combined Alright, so if you add up all the forces acting on an object, the net force, F net, is greater than 0. Okay? We will talk about this more in the future. Just keep this in mind, because for now we're just going to stick to the equation. Okay? So another way to think about it, another way to write the equation is that when you have more than one force acting on the object, it's the net force that's actually equal to m times a. Okay? Just something to keep in mind. We will apply this specifically to problems with the next video. But in general, this equation, your mass, when you plug it in, must be in kilograms. All right, so if the problem gives you grams, you have to convert it. If it gives you milligrams, you have to convert it. All right, that m in the equation is meant to be kilograms. If you plug in something else, you will not get the right number because you're using a unit that doesn't fit the equation. Okay, same thing, A is meters per second squared. All right, so if you have centimeters per second squared, something like that, conversions have to happen. Granted, I'm pretty sure I will always give you the acceleration in meters per second squared. It's the kilograms that you may have to convert. Okay? Convert those to kilograms. Always, always, always. So, units for force, we talked about this in the first video, but this is coming in again. Alright? Now, if you think about the fact that force equals mass times acceleration, well, mass is in kilograms. And then if you multiply that by the units for acceleration, oh, you get this one. These are the exact same thing. Okay? You can write it either way. Or, a really short, easy way to write it is newtons, which is a capital N. But it's one of those things where, say I give you the force and you have to find the acceleration, you gotta remember that the meters per second squared is in there. Okay? Which is how you get those units back out when you divide by mass. Okay? So, your equation, F equals ma, force is a vector, mass is a scalar, and acceleration is a vector. Alright, so force does have direction. And this will come in really important when we start free body diagrams with the next video. Okay? But force does have a direction. Usually, 99% of the time, F net is to the right if motion is horizontal. That way things stay positive. So, always draw horizontal motion to the right, that way it stays positive for us. Okay? Now, there's also your equation F equals ma. Sometimes you'll have to solve for acceleration. Alright, so if you want to solve for a, you have to move the m, which means you divide by m on this side, those cancel, and divide by m on that side, and that is how you get this equation. Alright? Or, again, starting with F equals MA. Hopefully these are much easier for you since we're starting with the multiplication. It's much easier to see, oh, I just have to divide. If we want to solve for mass, we have to move the A over, so these A's cancel, and that's how you get this equation. Okay? Then this is a couple of new vocabulary words that we will use several times throughout the rest of the school year. Proportionalities, it's a very conceptual way of looking at things, where you don't need specific numbers, you just look at the equation and you can tell that if one thing increases, that's going to have, and everything else, there's always one thing that stays the same, one thing that I tell you increases or decreases. And then you should be able to figure out what happens to the third thing. Okay? So, force and acceleration are directly proportional. Okay, so force, acceleration. When I talk about that, what that means is that your mass is staying the same. All right? So if mass is the same, let's just call that 1. All right? The way I always do these things is I kind of start with 1 times 1 equals 1. Because math-wise, that's true. Okay? Now, if we're comparing force and acceleration, all right, if we increase acceleration, so let's say mass is staying the same, let's double acceleration, what happens to force? Well, if you start with the 1 equals 1 times 1 and then make the change that is said in the problem, you can do it like this. What's 1 times 2? 2. So our force went from 1 to 2, so it doubled. Okay? Another way of saying that is for a given mass. So mass is staying the same. Bigger forces cause more acceleration. So if you increase force, acceleration will increase. You could also say the reverse of that. That bigger acceleration, so you can also, these two words are interchangeable. You can flip their order. Bigger acceleration causes more force. Okay? Same thing in here. You can also compare force and mass. Those are also directly proportional. So if we start with 1 equals 1 times 1, and then if we double, say we double the force, start the other way this time, we know that acceleration is going to stay the same, because that's going to be left constant. What number would I have to plug in for m to make that true? A 2. All right? So same thing here. For a given acceleration, so acceleration stays the same, bigger masses require bigger forces. All right? This should kind of make sense anyway. So if you think about it, what's harder to move? Something really big or something really small? And essentially the effort you put into making it move is related to the force. All right? Now, the tricky thing is mass and acceleration are inversely proportional. So this is saying that for a given force, all right, so we're starting with 1 equals 1 times 1, force is going to stay 1. All right, if I double the mass, make that a 2, what do I have to multiply 2 by in order to have this still equal 1? Right, that would be 1/2. Because 2 times 0.5 gives you 1. All right, so what happened here is that the mass went up, but the acceleration went down. All right, that should kind of make sense too. If you apply the same force to a cow and a rabbit, and you get both of them moving, but you apply the same force, who's going to be moving faster? All right, the rabbit, because the rabbit's smaller, so it's easier for you to get it going, and you'll get it going faster. All right, whereas the cow, with the same force, cow is a lot heavier, so applying that force is going to get the cow moving but much slower. All right, so this is a very conceptual way of talking about things, and you just got to remember that directly proportional means as one goes up, the other goes up, or as one goes down, the other goes down. Inversely proportional is the opposite of that. If one goes up, the other has to go down. Okay? This is probably the trickiest thing out of here. So let's do a little bit of practice. And what I want to do, since the answers are already on here, I'm just going to show you how you get through these. All right. So here we have an object with a mass of 10 kilograms. What is the force with an acceleration of 5 meters per second per second? Okay. So again, LESU helps with this stuff. So for that first one, we know that our mass is 10 kilograms. All right. And our acceleration is 10 meters per second squared. Okay. Our equation is F equals ma. So our first S is, oh, sorry, I copied that wrong. Our acceleration is 5. So that's going to be F equals 10 times 5, which ends up giving you 50, and then making sure that you include your units, newtons. Okay? Keep in mind you could also write kilogram, meter, second squared. Either way works. Newtons are just a lot shorter and easier to make sure you remember to write everything. All right, so if you have mass while keeping force constant, what happens to the acceleration? So I'm going to do this one in pink. So we're starting with 1 equals 1 times 1, and then, so we have the mass, so that's going to be 1/2. Force is constant, so that's going to stay at 1. And then we want to know what happens to acceleration, so what number would we plug in order to make that true? That would be a 2. So acceleration went from 1 to 2, so it doubled. So next one, we'll do this one in blue. If you double the acceleration while keeping mass constant, what happens to the force? Okay, so our mass, let's see, we're starting with 1 equals 1 times 1. Nope, we don't know that yet. Then you double the acceleration so while mass is constant, so it's like this. Then 1 times 2 is 2. So if you see, your force goes from 1 to 2, so it doubles. An object is acted upon by a force of 50 newtons. What is the acceleration for a 50 kilogram mass? So if an object is acted upon, let's see, go back to green on this one and we'll do our LESU. We know that F equals 50 newtons, all right, because that's a force. And we know our mass equals 50 kilograms. All right, our equation, we are solving for acceleration. So acceleration is force divided by mass. And then A equals 50 divided by 50. All right, so that's going to give us 1 meter per second per second. Another way to kind of know that is on top we have our force units, which are kilograms times meters per second squared. And then we are dividing by kilograms. You notice the kilograms cancel out, leaving you with meters per second squared. That's how you get those units out of there. All right. When you write newtons, it's a little bit harder to see that, so keep in mind newtons are also kilograms times meters per second squared. Okay? So make sure you do the online assignment, and I will see you in class.